Fyodor Minkin, let's welcome him. Good afternoon, Fyodor. Over to you.
Всем доброе утро.
Good morning, everyone. My name is Fyodor. I'm a technical director of GigaChat service, and today I'm going to tell you about our models, how we're developing them, what kind of research we're doing, what results we obtain. My presentation will consist of three parts. First, that's about our main basic model, which is called GigaChat text. The second one, that's about GigaChat multimodal. And the third part would be dedicated to how and what models we are offering for the open source so that the community could use that. So let us begin with the GigaChat text. The text model, that's the main GigaChat model, it underlies everything. It underpins everything, the knowledge, the ability to convey certain ideas, and the very first, actually, phase rests on GigaChat text. That's about pre-training. Pre-training across the human footprint that we can get and purify. In pre-trains, we're moving in three main directions. The first one, that's an easy way. So let us take a model and increase that, enlarge that, so we will train it longer, better, and the quality would be better and better. The second way is a little bit harder. So we take a model and we improve the data set. So it means that we take the whole internet, the human footprint in all the languages. We try to purify that and put that into GigaChat in order to train that using all the facts from all over the world. And certainly, we are improving the methods that we are doing that, and that would improve the quality. But that's a very difficult thing to be done, because starting from some moment, the internet would have a lot of noise, it would replicate the same information, and you would need actually more capacity to purify that. And the third way, probably this is the hardest way, to change the architecture. Usually in LLMs, we are using one or two or three architectures, and the whole world is using that. When we can move them, we can modify them, we can change them, we can study what architectures are more efficient. In this way, we improve the quality. Little bit telling you the story, cutting the story short, so we tried all the three journeys, all the three ways. So we actually took the mixture of experts architecture as an example, and we used to use the dense approach when actually computing next token, all the ways, all the nodes would be used. And on the picture, you can see how it all works. For instance, once we are computing the answer, you use all the parameters of GigaChat in order to improve the models. You have to increase the size of the model and make it training more complex. In the new architecture, mixture of experts, we're using a different approach. The knowledge is stored actually in a bigger quantity than you use in every next step of the generation. So the green blocks show the knowledge that would be activated once you are using the model. So it means that we can store more knowledge, and the inference, we can actually retain the speed of a small model. Every block stands for some domain of knowledge of the model. What happened to that architecture? Let's start with our smallest model, which is called GigaChat Lite. Lite model had a transformer size of 7 billion parameters, GigaChat 7b. And we trained a mixture of experts model using only just 3 billion active components, and all in all there are more than 20 billion parameters, but we're not using all of them. So first of all, we increased the training speed 60%, so it means that we are spending 6 times less of money that we spend on training. That's an enormous result. That's a great result. And besides, this actually model is 7% better because of the mean increase in pre-trained metrics. So in essence, this model actually has better quality, is 2 times faster and several times cheaper. So it supports 131 kilo of context. This is a little model we have tested our approach. We got very pushed results and we moved forward. We trained the Pro model, so the train speed increased 34%. As far as the bottleneck for a mixture of experts model is the communication rather than computation, because for computation you need less parameters, but all in all you need more parameters, so the training speed decreases a little bit, but inference speed is quite good. I mean, the profit from the inference speed is the same, so 70% cheaper, and actually it is 5% better than the old version of GigaChat. So the mean metric increased 5%. Besides, what we have done, we increased the speed of training, and also we are working on increasing our pipeline training, what we're doing. So we did our library based on Giga FSDP. We have rewritten that, and it has more optimizations to be trained on hundreds and thousands of nodes. We are doing CCL optimizations. We are reducing the memory allocation. We are improving the asynchronous communications. All these areas are important to train the models faster over the year, actually. Now we have decreased 50% the memory consumption, and now actually the train speed is 40% faster, so our models become cheaper. We can use them faster, and we can train bigger models, and in essence, we decrease the costs. A few words about the future of our training. Let me tell you the following. We are investing actively into making sure that we decrease the idle hours of our video cards using SCCL operations. Once the network communicates with the training process, we can do computation on a different batch, and there will be no idle hours because of the lack of communication. So for mixture of experts models, that's very important. Moreover, we're investing into less bits. Small model training helps us actually to increase the speed almost 30%, but less bits we are using in computation, the less stable training is. Still, it can increase the train speed. So at the small models, we can keep the quality compared to the 16-bit approach. A few words about the architecture. I've already done that. Now a few words about the pre-trained data. Over the year 2024, we managed to increase the datasets 4 times. We added 8 new languages actively, so it means that we have added a lot of active data. We actually introduced new filtering methods as to how this or that web page is useful for GigaChat. And we are investing heavily into synthetic data, as I have already said. Good data on the internet run out, and it becomes more and more difficult to obtain them, to filter them. And therefore, we understand that in some domains, you can make synthetic data that would improve that domain. We'll speak about that a bit later. First and foremost, that's about mathematics. All the teams that are dealing with the LLMs are improving the mathematics. This is one of the biggest challenges for the LLMs, and we're investing heavily into that. We have made a pipeline to generate artificial data. So it means that there are no such data in real life, but we're using different ensembles and other meters in order to generate these artificial pipelines, and we can compete against Numina. And once we're training the pre-trained model, the mathematics of synthetic dataset increases better than in the open dataset. So we're going to invest into that, and GigaChat would have better mathematics. The same is true for code. We added only 1% of the synthetic code to our data sets, and we increased the metric by 60% using a very small model. Why it works like that? Because synthetic data are very good. It's very easy to verify the code and the mathematics. You can actually check the quarters of computation and calculation, and you can generate that data easily and train the network to address those domains better. So I already covered the pre-train code improvement of data sets. This resulted in a big progress that we did in 2024. But after we have trained pre-train, we have actually to do supervised fine-tuning so that we could address the applied tasks. 2023, this was the year when we launched GigaChat and focused on its basic knowledge, basic features, basic guides. In 2024, apart from that, we focused on science. That's about STEM, that you see on this slide. We improved physics, mathematics, chemistry, and other sciences. Besides, we focused on empathy and humanity, because such systems as GigaChat can do that very well. And certainly we focus on business application of GigaChat, scenarios such as G-stone answers, search, etc. Let me say a few words about STEM, about the science. There are about 350 specialists engaged in STEM who, along with us, are training GigaChat to do something. We are focusing on quality. Quality is our priority, as well as complexity. So the volume is not so important. We are using that for complex science. We take an approach when the system has to think for some time before providing an answer. And our specialists are generating the data in the format of chain of thought. Chain of thought. This is about the functions. So this is true for the lines that I've shown before. And this is ability to retrieve the external AP. As you know, LLMs have no access to internet. This is an encapsulated model in order to understand the exchange rate, for instance, or the weather forecast. The model would need internet. To make sure that GigaChat could use the external tools, we are developing the functions technology. On that slide, you can see the concept of how these technology work. The user, for instance, would say, I have AIJ journey conference tomorrow and have to get up 1 hour earlier. GigaChat understands that it is addressing the external information because the GigaChat doesn't know what kind of alarms the user has, and it checks get alarms, understanding what alarms are there, understands that there is an alarm with certain ID, with certain time tomorrow 8:30. So it understands that probably you have to set the alarm earlier, engages the function change the alarm, and retrieves the same ID and sets the alarm 1 hour earlier. Then it does it and summarizes what it has done. So we are incorporating that function into GigaChat. And for instance, we announced that actually you have now functions as set the alarm or change the alarm, and it uses that in its generation. Inside, the functions would be divided into zero-shot function. This is the function that was given to the system by the user, for instance. It might be the business-specific function, for instance. You may look for some mining companies in your city, and so the GigaChat has to be able to work with that. It has to be able to understand any description of the function and understand out of its knowledge and description of the function when it has to be retrieved. And in-house functions, because we have a lot of applications of GigaChat, lots of applications of GigaChat functions. For instance, our B2C may draw very well with the help of our Kandinsky AI, or smart house or alarm actually could be engaged. Having some impact on GigaChat and training that we can outperform the best systems from all over the world using in-house functions. GPT-4 doesn't do in-house functions so good as GigaChat. You can actually test that at SDK GigaChain. In such an SDK, you can get connected to GigaChat, try any functions. It would be very easy to use agents on GigaChat system. And I would say that that SDK is quite popular. So the external users install that 15,000 per month, and certainly for free. And we also publish hundreds of cases how can use GigaChat. So we have improved pre-trains, we have improved alignment within an SDK. And another step forward would be telling you about GigaChat Max. GigaChat Max has already been launched. It was done in October. You can find a technical analysis what model is about, its benchmarking against the competitors. But now let me tell you more about some of them in more detail. So GigaChat Max, this is our smartest and biggest model available in our line compared to GigaChat Pro. The datasets that are being used across the world, English language datasets, there is a great profit, especially in terms of the code, research, guides, mathematics. Apart from the metrics that the whole world is reading in English, we certainly try to make that in Russian, and we are counting the metrics in Russian. And in Russian, GigaChat Max compared to GigaChat Pro increased 20% in terms of the open benchmarks. In terms of the closed benchmarks of groups of companies, we see an increase by 13%. So it means that increasing of the model entailed a bigger increase in all the benchmarks and improvement of the quality of the model. Let me also now to the STEM. We show 5 sets. 3 of them are in-house sets. In future, we actually planning to put in the open source with the help of 350 specialists. We made that in Russian, in biology, chemistry, and mathematics, and in essence, there are dozens of more sciences that I have not put on the slide. And we show actually comparison in open source in English, and we see that GigaChat Max outperformed in terms of science our network, GigaChat Pro, which is smaller and faster, and it is almost the same as GPT-4. In Russian, it is a little bit better. In English, we see the parity is the same. Another, actually, goal is to launch ChatGPT-4, our latest, and in terms of chemistry in Russian, GigaChat actually can compete against for our latest. GigaChat Max would improve its capacity in STEM with the help of our very cool specialists. I would like to thank them, first of all. Apart from the automatic benchmarks, we're also checking ourselves in different areas. For instance, we are calculating the metrics in English language. That's the hard benchmark. And the arbiter is the ChatGPT, the best English language model, and assesses the results of different networks. You can see the GigaChat Max defeated ChatGPT of different versions. For instance, ChatGPT 3.5, but lags behind the English language models a little bit. Also, we are checking that in the Russian language, GigaChat Max is one of the best models in Russian. It outperformed all the ChatGPT versions and open source versions at the moment. And in essence, GPT 3.4 Turbo and others are all lagging behind. These are the metrics. We are being assessed by ChatGPT-4. If we outperform ChatGPT-4, it seems that actually you have to do some manual comparison. And we did side-by-side comparison. And we compare ChatGPT 3.5 Turbo and GigaChat Max. GigaChat Max is outperforming because the formatting, editing, the quality of answers is better, and in terms of knowledge, in terms of dataset and the facts and accuracy, we are equal with ChatGPT-4. So next our aim would be ChatGPT-O, and I hope that next year we'll have even cooler models so that we will outperform our competitors next year. Speak about the models, I have to mention runtime. This is how we are launching our models and how our service works in the real life. First thing we did this year, that's about moving to the latest H100 GPUs, and it benefited all the clients and employees of Sber. Besides that, also we implemented KV cache reuse, and that's a very sophisticated thing because it caches parts of the user inquiries, and it works the following way. So once we get an inquiry from the user, query, it would be divided into some pieces interconnected between each other, and you look in the cache, the common prefix in that cache. Very often those prefixes would overlap, and very often we would get a big part of the computation, and instead of doing that, we get the ready-made result from cache. On the flowchart, you can see the time to first token GigaChat Pro. So this is the speed of obtaining the first token from the model, and compared to cache, it works much faster because there is a lot of overlapping between the answers and queries of the users, and with the help of that technology we can improve the time to first token 17 times. And it has already been done in the production everywhere. Therefore, over the year 2024, we accelerated the system very much. At the moment, actually, the FP8 now is in the pipeline and will give us 1.7 times increase in the speed of all our model.
Well, I'd like to inform you about what we have done over the past year. We've optimized architectures, our runtime, the cores and codes, so that the implementation of networks is sped up, and GigaChat now runs 3 times faster than last December. FP8 and cache research of ours will make our GigaChat even faster. So now let's turn to our multimodal capability. This year we have rolled out GigaChat Vision. So GigaChat is capable now of deciphering images and text caption in English, Russian, and other language. So excellent reading in Russian, English, including handwriting. General knowledge stays the same. And the conceptual schematic is in the screen. We have the GigaChat with tokens that have vector embeddings, and the multimodality is carried out as follows. The image goes through an encoder, and then adapter is an important pillar. We try to imitate the image, the pic, so that GigaChat would understand the image tokens as well as it understands the text tokens. So the GigaChat learns to understand, to perceive new modalities, and we'll have more modalities in the future. GigaChat Vision is good at working with functions. We can generate text to image and image to image. Like you can say to generate the Maldives sunset, and GigaChat would do so. Now we can edit. We're adding functionality on editing the user's images and editing the GigaChat generated images. You can try that in our booth. At our booth, we're running it in test mode. GigaChat can process documents, native reading of EPUB, PDF, and more. We have had the document processing speed up to 5 times over the past year. So you should use GigaChat and GigaChat documents and summarize and ask questions and I keep using that, and our pipeline for the documents is as follows. We will be adding multimodal documents like Excel and presentations so that GigaChat would understand and read your presentation and suggest steps to improve that. And our next modality is audio. We have very good speech solutions. So it's better. We want GigaChat to be able to understand and decipher speech of an individual and the people surrounding him. A Giga acoustic model is something we'll talk about later, and we try to simulate text tokens, and GigaChat can perform audio tasks like recognize speech and more. And we are comparing ourselves to Gemini and GPT-4o. And it's curious that the first column in speech recognition, GigaChat Max, is ahead of everything in existence. When we tested GPT-4o at a certain data set, GPT-4o would decline to transcribe and would decline to decipher audio clips. Gemini has better metrics, while at the same time GPT-4o is good at translating. GigaChat Max can also do so. We have good metrics ahead of Gemini. So now we are a state-of-the-art speech recognition system in Russian. We will further enhance that, and next year it's going to be a commercial product, and we'll be testing that. And GigaChat Audio, just a couple examples what it says. It can understand speech in different languages, like a video clip can be summarized by our GigaChat, and answers to some of the questions can be found and help analyze long videos, and we always lack time to watch those to the end. So it also is capable of producing some instructions like writing a code. In this instance, the current speech recognition system, the Telegram in this case, would not understand IT terms, while GigaChat Audio is a good code writer, so it is capable of understanding that. It would also decipher and recognize the scene and use that in dialogue. And you can just chat with our GigaChat using your voice. And next step would be merging audio and video. We are successful in that. GigaChat multimodal has images and audio, and the metrics decline in performance is not so great, and so it is at the juncture of modalities. We now operate at the juncture of modalities, and we would really like to produce a system capable of recognizing the video flow in real time and answer questions and be a new generation assistant. So we'll have lots of interesting things next year, and the final phase of my presentation is open source. So this year we suggest our community, the data science community in Russia and worldwide, to probe the following. First of all, it's our acoustic model, Giga AM, speech recognition model, and it is capable of processing speech and emotion, perception. So it is a baseline model for audio. Giga AM first version 1 came out last year. So this model is the best in class in Russia, ahead of all open source and commercial speech recognition systems. Apart from that, we've been able to find means to enhance it further. Giga AM version 2 out now. So the baseline checkpoints of GigaAM is available, and there's also available a checkpoint to recognize speech. Here you can see the fine-tune figure. The first curve is for last year's GigaAM, and the other line is for this year's. So your QR code will lead you to that, and we'll produce a big article describing how we did that. Shortly it'll come out, and GigaAM first version would defeat everything we have across the board in this country, and GigaAM version 2 is outperforming it immensely, hugely, way ahead. You can use it in research, in your work, anywhere. So please try that. I urge you to do so. We are proud of that. We take pride in this. So another point I'd like to mention is an inalienable element of any language models, Giga embeddings. You should have access to a search index. So in-house we have been dedicating a lot of time and effort to that. We have lots of cases based on search. So, and we are now designing a major technology to transform text to vector and then search across the vectors. So embeddings, large context embeddings, enjoy a lot of demand. So it is so hard to expand context, and when we work with LLMs, we need actually sometimes to index a big text and use that in generation. So our Giga embeddings are based on Giga Chat with 3B parameters. We curb it to 2 billion, though. So the context size is 4,000, several times more than E5 multilingual. It has one of the leading places through Room tab, a benchmark to score the embeddings, and you can find it through the QR code with an MIT license. And the final point I want to share is the news that we are going to open source our GigaChat Lite. So as the first mixture of experts model, we have pre-trained it with 10 T plus pre-trained tokens. It outperforms Llama 8B 2 times faster. GigaChat Lite on Mira performed better than our GigaChat Pro, which is commercial. So GigaChat Pro will definitely so it's MOE is a mixture of experts model. So we wanted to find out what type of experts these are. So in the open source, we have actually chosen dataset pile, and texts have been labeled and marked and by domain, science, medicine, etc. And we wanted to find out whether our system can separate the data set into categories. So it breaks down it in categories well enough and can spot a specific domain. So we do that with the help of the GigaChat Lite model, and we analyze which type of experts are used in inference. And experts of ours are kind of very specialist ones, specializing in a topic. So I think that is going to be very interesting for the researchers. We will issue an article at Harbor. And I'd like to conclude my presentation sharing 3 links. On the left-hand side is a QR code to our technical channel, where we provide news in the feed about our technical designs and our new solutions and our results and our outcomes. The big QR code in the middle is a link to our web version of the GigaChat. GigaChat Max. Use it in your day-to-day life, and on the right-hand side is our playground link. Is a B2B service. You can customize GigaChat and come up with your own scenario for GigaChat and test it, catering to the business. So thank you very much for your kind attention. This brings me to the end. Thank you very much, Fyodor, for a very detailed presentation. Everybody was fascinated, I'm sure.